Good morning, Algebra 1 students. I hope your day is going well, whether you're watching this in the morning or in the afternoon, or maybe at, midnight. But either way, our notes for today, we are actually going to skip to section 9.6. So if you remember, the last time I was talking to you through a video, we were doing 9.4, solving using square roots. We're going to skip to 9.6, which is solving using the quadratic formula. The section that we skipped is 9.5, which is solving by completing the square. It's a special type of solving that's a little bit above the scope of the course for Algebra 1. So you will learn how to complete the square in Algebra 2, and you'll use it a ton in pre-calculus. But for Algebra 1, we are going to skip completing the square. So, to solve using the quadratic formula, the first thing you need to know is the actual quadratic formula. So first I want to remind you that if we have a quadratic and it's in standard form, we usually call it ax squared plus bx plus c, and we could say y equals ax squared plus bx plus c. Hopefully that looks familiar to you. Remember, we talked about what a, b, and c do to your quadratic. We know that negative b over 2a can help us find the vertex and the axis of symmetry of our graph. So this brings us back and ties us back into chapter 8. But one way we can solve quadratic equations, so remember, solving quadratic equations is what we've been focusing on in chapter 9. We've solved quadratics by graphing them and finding their x-intercepts. We've solved quadratics by factoring. We've solved quadratics by square rooting both sides. So our final method for solving quadratics is using the quadratic formula. So your quadratic formula is x equals, because remember in all of these other ones you've been solving for x, so it should make sense hopefully that it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that is your quadratic formula. You do not need to have it memorized. Remember, you would normally get a note card if we were in person and you were taking a test in person on this. So I do not expect you to have it memorized. Although, if you've clicked on the video I posted before this first notes song, or this first notes video, you might have heard the song that goes along with Pop Goes the Weasel. So I did post a little quadratic formula song for you in case you need help just remembering where things go. Just make sure you write it down correctly every time you're using it. Otherwise, it will be a little hard to actually use it if you're not writing down the formula correctly. But that's our quadratic formula. So as we go here, let's try solving our first problem here. So we have k squared minus 3k minus 10 equals 0. If I use the quadratic formula of x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, it'll probably be helpful for us if we label what a, b, and c are. So what is our a value? What's our number in front of our k squared? Just 1. When there's no number in front of it, it's just a 1. Our b value is negative 3, the number in front of just k, and our c value is negative 10, the number by itself. So now that we know what a, b, and c are, we can plug them into this formula and simplify and solve. So we have x equals negative from this negative, and then negative 3 from this. So negative 3 plus or minus the square root of negative 3 squared, because that's our b value, minus 4 times a, which is 1, times c, which is negative 10. Make sure that all those numbers are underneath the radical, all over 2 times a. Alrighty, so now we want to simplify. Think order of operations. So PEMDAS. What do we do first? Parentheses. There's nothing we can simplify inside the parentheses. All these parentheses here just mean multiplication. So the next thing is exponents. One thing I need you to know, a square root is considered an exponent because you can write square roots as exponents. I don't know if you remember that section we did before Christmas. We said the square root of x is the same thing as x to the 1/2. So that means a square root is an exponent. So we're going to simplify our square root first. Now you might just want to type this straight into your calculator. If not, you can do this in your head. Let me pull up here my calculator and show you how to type this into your calculator. Hopefully you have your calculator with you at home. Okay, so if we're trying to type this into our calculator, we're going to do the square root of, parentheses, -3 squared minus 4 times 1 times -10. Sorry, that's cut off here. And we get our answer to be 7. So when you take the square root of all of that stuff together must be 49 because the square root of 49 is 7. So we get x equals -3 plus or minus 7, and 2 times 1 is just 2. Now, if you want, you could type all of this in one go, this whole massive fraction into your calculator, but I do see a lot of students making mistakes when they're doing that. So I recommend just typing in the square root part and then going from there. So to get our two x values, remember for a lot of these you have two x values, we are going to break this into two separate problems. So x is either -3 plus 7 over 2, or x is -3 minus 7 over 2. So figuring out the answer to these, -3 plus 7 is 4 over 2, which is just 2. And this is -10 over 2, which is -5. So that means x equals -5, or x equals 2 are our answers there. So some of you might say, well, that was a really complicated way of doing this. One way the quadratic formula is better than some of the other ones in certain situations is it can always solve your quadratic, where not all of the other ones always work. We couldn't always factor. We couldn't always graph and get an answer from our graph, because sometimes our answers are decimals. So that's one reason the quadratic formula is good here. Let's go on to problem 2. And I'm kind of out of room, so I'm actually going to write it off to the side here and just go off to the side. So r squared plus 4r plus 4 equals 0. Let's remember our quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Again, you don't have to have that memorized. I just want you to be able to actually use it. Okay, so now that we're going on to solve this using the quadratic formula, let's first label our a. Our a value is the number in front of the r squared, so it's just a 1. Our b value is the number in front of the r, so it's just a 4. And our c value is this 4, the number by itself with no variable. Alrighty, so setting up our quadratic formula, we have -b, so -4 plus or minus the square root of b squared, so 4 squared minus 4 times 1 times 4 all over 2 times 1. Okay, some of us might want to type this into a calculator. I think I can probably simplify that square root without typing it into the calculator. So remember, order of operations, we simplify the square root first because that square root acts as an exponent. So 4 squared is 16 minus -4 times 1 is still -4. Times 4 is 16. 4 times 4 is 16. So we have 16 minus 16. So this is really -4 plus or minus the square root of 0 all over 2. But what's 0? What's the square root of 0? Just 0, right? So that goes away completely. And we just get -4 over 2, which is just -2. So we just get one answer here. If you remember, what your graph would look like then is your graph the vertex of your graph is hitting the x-axis at -2. There's only one answer here. So x equals -2 is our answer for problem number 2. I'm going to pause there because this video is longer than intended, but we will go through some other problems as we get going here.